Hey everyone, in this video, we are going to solve an example for proving that a given language is not regular, using pumping lemma. We will use the pumping lemma to prove that the language L equals a to the power I, b to the power I, such that I is greater than or equal to 1, is not regular. Step 1. Define the language L. The language consists of strings where the number of A's is equal to the number of B's, such as L equals AB, AABB, AAABBB. Step 2. Apply the pumping lemma. We assume that L is regular, meaning it can be accepted by a finite automaton, FA, with n states. Let this FA be represented as M equals Q, sigma, delta, Q0, F, where Q equals set of states. Sigma equals input alphabet A, B. Delta equals transition function. Q equals initial state. F equals set of final states. Selecting a string omega from L. To apply the pumping lemma, we choose a string omega such that length of omega is greater than or equal to n. Tip: always select a string from the third string onwards in L to avoid trivial cases. Let's take omega equals AAABBB. As per the pumping lemma, we divide omega into three parts. Omega equals xyz such that length of xy is less than or equal to n. Length of y greater than 0, y is the repeating portion. A possible decomposition is x equals AAA, y equals b, z equals bb. Note, the choice of x, y, z may vary, but the final contradiction will always hold. Step 3. Find a contradiction. By the pumping lemma, for any I is greater than or equal to 0, the string omega equals x, y to the power I, z must still belong to L. Let's check for different values of I. For I equals 0, that is to remove y. Omega equals AAA dot operator, b to the power 0 dot operator bb. Omega equals AAABB. Not in L, as the number of A's does not equal number of B's. For I equals 1, to keep y once. Omega equals AAA dot operator, b to the power 1 dot operator bb. Omega becomes AAABBB. Valid in L. For I equals 2, to repeat y twice. Omega equals AAA dot operator, b to the power 2 dot operator bb. Omega becomes AAABBB. Not in L, as the number of A's does not equal number of B's. Since omega is not in L for I equals 0 and I equals 2, we have a contradiction. Conclusion. Since the assumption that L is regular leads to a contradiction, we conclude L equals a to the power I, b to the power I, such that I is greater than or equal to 1, is not a regular language. Thus, we successfully proved using the pumping lemma that this language cannot be accepted by any finite automaton. Subscribe to the Hidden Engineers for more such content.